Hello friends, this is a video lecture on water demand or draft and their variations. Why do we need water demand and drafts? These are needed in order to calculate the capacities required for designing an individual components in a water supply system like pumps, filter mains and then intake structures. In order to design those things, we need to know the capacity to which they are to be designed. Hence, we require the water demand for designing these systems. See, the variations in demand can be seasonal, daily and hourly. Seasonal variations means that the water consumption is more in summer than in winter and rainy seasons. Daily variations denotes that the water consumption is more on Saturdays, Sundays and other holidays rather than in the working days. If you see to the hourly variations, you can observe that the consumption in the early hours of morning is generally small. It increases sharply as the day advances, reaching a peak value between 8 to 11 a.m., then decreases sharply up to about 1 p.m. and it remains constant up to 4 p.m. Then again it increases and reaches a peak between 7 to 9 p.m. and then it falls gradually as the late hours of the night comes. Why do we need this assessment of normal variations? Because water supply units are designed based on the variations of the demands. If you take a situation where this is the period where you are utilizing maximum water, like your consumption is more, and at the same time you are getting a fire demand also, then there is a sudden and a heavy draft in that case. So our systems have to be ready in order to meet those demands also. Hence, we derive the maximum demands from the average demands. We are multiplying the average demands with a multiplying factor to derive the maximum demands. Maximum hourly demand, maximum daily, maximum weekly demand and maximum monthly demand. They are derived by multiplying factor with their average demands. How do we derive this multiplying factor? This can be obtained from Goodrich formula. You see, the ratio of the maximum demand to the average demand is obtained by multiplying 180 to the time, which is represented in days and has a power of minus 0.10. So, if it is a daily demand, your time variation is 1. If it is a monthly demand, your time variation is 30. By substituting the respective t values, you can obtain the ratio of maximum to average demands. For example, I have given you the calculation for daily variations. For daily variations, we can take t is equal to 1, and by substituting t is equal to 1 in the Goodrich formula, I am obtaining 180%, which when calculated as a ratio value by dividing it by 100, I get as 1.8. So multiplying my average daily demand with 1.8, I can get the maximum daily demand. So simultaneously you can calculate for weekly and monthly demand. So friends, this is your activity. Pause the slide for 2 minutes and calculate the ratio of maximum to average for weekly and monthly demand using Goodrich formula. Please write the solution in paper. Another term which we need to get familiarized is coincidental draft. Take an assumption. There's a fire breakout, particularly during the maximum consumption time. So at that time, you can't depend on the average demands. You have to go for a total draft which takes the sum of the fire demand and the maximum daily demand or maximum hourly demand, whichever is more. That we will take as a total draft. Coincidental draft is particularly the sum of maximum daily demand and the fire demand. Please note down that the fire demand is calculated based on the National Board of Fire Underwriters formula according to the Indian standards. So here is the utilization of demand for each water supply unit. Depending upon the sources, you align the supply units. If in the case of river, you will take intake structures, filters and other units, pumps, and then distribution system and pipe main. If the source of supply is a reservoir, we will take a service reservoir, filter and other units, pumps, and then distribution systems. Pumps may be needed or it is not necessary in this case. So note down, for intake structures, the demand for design is a maximum daily demand, which is the same in the case of service reservoirs and pipe mains. For filter and other units and pumps, we are adding a reserve with the maximum daily demand. Hence, you are not taking 1.8 as a multiplying factor, you are taking 2 as a multiplying factor to the average daily demand. And then you are using this value for the filters and other units and pumps. While coming to the distribution system, the coincidental draft or maximum hourly demand, whichever is more, you are considering that one as the demand for designing the capacity of the distribution system.